Welcome back to our statistics learning session. Today we'll be talking about errors of a statistical test. Last time we talked about C, and our question was, what is the right way to choose C? How can we optimize our choice such that when you choose C, we have the less probability of error? Now, in today's session, we'll focus on the choice of C. The choice of C should be in such a way that it helps to improve the performance of the test we are creating. Because every test makes a mistake, we want to choose C in such a way that it reduces the error made by our test. And that's the optimization we need to focus on. Choosing the right value of C helps to reduce the error made by our test. That's the focus. That's the main thing you need to focus on. Let's dig deeper into the errors. Rejection region. The first thing about error is the rejection region. What is the rejection region? A rejection region is a subset of possible sample values that would lead to a rejection. And what is this rejection region defined as? It is defined as value of x that belongs to the sample space En such that it produces the test function of x equal to 1. What is the test function here? Test function is a indicator, and this indicator function is based upon the sample values it takes to compute 1 or 0 based upon the values it intakes. Now, this test function is an indicator, as I just said earlier. What is indicator of? Is indicator of something. It is indicator of test function is indicator of whether x belongs to a rejection region. It is repetitive, I know that, but let me repeat it again. Test function is indicator of whether x belongs to rejection region. And what is the rejection region? Rejection is region is all values of x that produces the test with when its value outputs 1. That means it rejects the h naught. Now moving on to errors. Specifically, when you talk about errors, there can be two kinds of error. One is claiming that there is a falsely claiming that there is a discovery and missing the claim, missing to claim that there is a discovery. There are two kinds of error. Now let me just plot this into a grid so that we can, it will be easier to comprehend. This is a reality, this is a claim, H0, H1, H0, H1. If it's a reality that it's H0 and this also claims that it's H0, then there's no problem. If reality is H1 and this claims H1, there's no problem. If the reality is H0 but it claims it H1, then that's a type 1 error. In reality, it is H1 but it's claiming that it's H0, then it's type 2 error. That's how the error has been named. And it is important to remember what type of error is type 1 and what type of error is type 2. When there is type 1 error, we are rejecting H1 and giving favor to H0, H1, saying that there's some discovery. And in type 2 error, we are not rejecting H1 even though there is something to be discoverable. When we make this kind of error, there's some probability that we'll make this kind of error. And this probability of making this kind of error is called type 1 error. And same as type 2 error. Type 1 error and type 2 error are just probability of making that kind of error. How do we denote type 1 error and type 2 error? Type 1 error is denoted by alpha of psi and type 2 error is denoted by beta of psi. Type 1 error is a function of test. It is a function of test. That means it depends upon the test that is used to judge whether it is type 1 or type 2. It depends on that. Each theta type 1 error resides within H0. Type 1 error resides within H0. Why? It resides in H0 because it is focusing on it is it is focusing on theta naught values which have probability of producing rejection. Let me write down graphically. Let this be theta naught and it is looking at all the theta in this range and calculating probability of each of these theta values in this range, theta naught range, and saying that this is the probability of this is the probability of producing indicated as 1 by test when theta belongs to this value within this theta naught range. It calculates for all of that. And what it's saying is that when we produce the theta naught p theta, that means this is the sum of the all the probability of theta naught 1 probability of theta naught 2, where theta naught 2 belongs to theta naught. It is calculating probability of all the probability of each of this theta and summing them together and giving you one value, saying that this is the probability of producing the type 1 error in theta naught. Therefore, this is a function that depends upon ranges of theta within the theta naught that outputs the certain probability score when test produces value as 1. This is complicated, but this is also simple at the same time. If you understand it well, this is also simple at the same time. So what do we understand by type 1 error? Type 1 error is a probability score given to all the values of theta naught. It is sum of the probability of producing type 1 error for all the values within theta naught. It is sum of that. That's a key word here, sum. It is not for the only one point, but it is sum of the probabilities of all the values within theta naught. Sum of the probabilities. Sum of probabilities of all theta within theta naught to produce or reject H naught. That's what it's all about. Let me quickly summarize what we discussed today. We discussed about the rejection region. We talked about what is the definition of rejection region. We also talked about test indicator and what is indicating. It is indicating that whether X lies in the rejection region. It is repetitive, but that's what it is. Then we talk in detail about type 1 error of test. We said that it is sum of probabilities of all theta within theta naught to reject H naught, even though when H naught is true. That much for today. I will see you in our next learning session. Thank you so much.